RCHUB International Foundation for Research and Education, and ISO certified.
Okay, so I hope my PPT is visible right now. So when it comes to statistics, the fundamental thing what you have to know is that when the statistics, this completely deals with it's analyzing and making interpretation and presentation of the data. So what statistics is all about? You need to collect data, you need to organize it in such a way that it is easy for you to analyze, and then you need to make analysis. You need to employ proper statistical technique and then make interpretation and presentation. So this is what statistics is all about. So when it comes to statistics, the first and fundamental thing what you have to know is the sample. What I taught you yesterday. A sample is nothing but a representative of the entire population. So you cannot go collect your data from the entire population. So you need to select a representative so that they may act behalf of the entire population. And you, with a significant amount of sample, what you're going to consider, the result will be exactly or something approximately replicating the total population result. So when it comes to statistics, we think that statistics is very difficult and statistics has many techniques that we need to understand prior before we do. But I tell you what, if you go on from the fundamental, from the root, we can differentiate statistics into just two segments, So first is the descriptive and second is the inferential statistics. So under inferential statistics can be further classified into two types, that is prescriptive and predictive. So remember this one. So when it comes to statistics, it can be just classified into two aspects. One is descriptive statistics and another is inferential statistics. This inferential statistics can be categorized, subcategorized into prescriptive and predictive. So you may have a question, what is this descriptive statistics? What is this inferential statistics? So I tell you what, this descriptive statistics generally deals with a central tendency or dispersion or distribution. So to put it more colloquial, for easy understanding, so what this exactly means is that it means about means, median, mode, standard deviation, kurtosis, and skewness. That is what is descriptive statistics is all about. So what does this mean? What is this median? I tell you what. So mean that I will teach you while I open the SPSS and we deal with the real sum. So, okay, then inferential statistics. Once again, I tell you what, when it comes to SPSS or when it comes to statistics, apart from the descriptive statistics, we do statistics only for four important reasons. Only for four important reasons. Whether the two variables considered for the study or two or more variables considered for the study have significant association with one another. This is the very first reason. Yeah, the second is the significant relationship, whether the two or more variables that we have considered for the study have significant relationship or not. And the third is that whether one variable, what we have considered, has significantly influenced or impacted by the another variables, or is there any significant difference among the variables. So it is for these four purposes we do all sorts of statistics. All statistics falls into these four categories. I told you inferential statistics can be classified into prescriptive or predictive, but generally we do statistics for just four reasons: to find the association between the variables, or to find the relationship between the variables, or to find the influence of one variable on the another variable, and to find the significant difference between the variables. Now getting into the topic. We might have read about different types of data like scale, ordinal, rational. So I tell you what, when it comes to SPSS, it doesn't actually, when it comes to statistics, there are only two different types of data. One is categorical and another is metric. If you able to identify what is categorical data and what is metric data, obviously you will be in a position to tell what kind of analysis that I can, or what kind of statistical technique that I can apply for my questionnaire or apply for my analysis. So this is the fundamental thing. So let me repeat once again. So when it comes to statistics, we do statistics to know the description or descriptive in nature, or how for the data, to know the descriptive nature of the data, or we do statistics for 4 reasons. What are those 4 reasons? To find a significant association with the variable, to find a significant relationship between the variables, significant influence between one variable on another variables, and to find the significant difference among the variables. So the first and foremost thing what you have to understand is that when it comes to statistics, there are only 2 types of data: categorical and metric. So what is this categorical data? Any data that forms a group. Say for example, male, female, smoker, not smoker, person who prefers tea, who prefers coffee, income level, high, low, medium. So these kind of group is known as a categorical data. So what is a metric data? Any data that deals with numbers. I tell you what, any data that deals with numbers or a Likert scale based question where the population size is beyond 16, then you need to consider that Likert scale question or the data that is in numbers as a metric data. So I hope you are have you understood till now, ma? Because this is the fundamental concept. Before we get into SPSS, we need to know this. Okay. So have you understood? So we do statistics only for these 4 reasons. Apart from this, we do statistics to know the descriptive nature, which is known as descriptive statistics. And there are only 2 types of data with respect to statistics, that is categorical and metric. So categorical or nothing but the data that forms a group, that is male, female, something like that. So metric data is something that is deals with numbers. Say for example, what is your age? Dash. It could be anything. Say for example 32, 34, 38, 41, 42. So this is a number, right? But in case if you have categorized into categorical question, say for example, what is a age, like option A less than 25, option B 26 to 35, option C 36 to 45, option D above 50 or above 45. So now it becomes a categorical data. You got me? If you put just age and dash, it could be of any number. It's a number. But if you have categorized into 4 options or 5 options, then it becomes a categorical data. Remember this, ma, because many people make mistake. Many people assume that the age, since it's a number, even if you give it as an option, it should be considered as a metric data. No, only the numbers or any Likert scale based questions that have more than 60 as a sample size, it could be considered. And if the data are normally distributed, you can consider as a metric data. So you may have only 4 different combination, ma. So if variable 1 is categorical data and even the variable 2 is categorical data, you can do only significant association test. So if you have 2 variables, say one is categorical data, say for example, say for example, smoker, non-smoker, cancer patient, non-cancer patient. So first question is, are you a smoker or a non-smoker? The second question is, are you a cancer patient or a non-cancer patient? So taking this into consideration, you could say that you have made an analysis, you found that most of the smokers are cancer patients. So here you could say there is some association between smoking and cancer. So this is how, if 2 data are categorical, yes or no type questions. So any categorical data question, you need to perform significant association test. What are the significant association test? There are only 2 with respect to SPSS. One is the chi-square analysis or the correspondence analysis, or we can say optimal scaling. So I will teach you how to do that. So you may ask me a question, sir, if we can say smoking and cancer has relationship. No, we cannot say smoking and cancer has a relationship. It is not, it may sound logically right, but speaking rationally, it is not right. I tell you why. So if 2 data are metric, then only we can do significant relationship test. Say for example, we have Sita Raman. Sita Raman and myself are running. We are running a race, and Sita Raman have covered nearly 100 meter, and I have covered only 80 meters, which means we have relationship. We are doing the same action. We are running. So we have significant relationship. When Sitaraman covers 100 meter, I covers 80 meter. So we have 80% relationship. So at the same time, because we are the running distance or measured in terms of distance or speed, kilometer per hour. Once again, if Sitaraman runs in a forward direction and I run in a opposite direction, then once again we have a relationship because we are doing the same action, we are running. But the thing is that Sitaraman is moving forward 100 meter, I am moving backward 80 meters. So we have negative relationship. So the relationship could be positive or negative, but association can never be positive or negative. So that is why if both the data are metric, so if both the data are numbers, say for example GDP, which is a number, GDP, which is a number, and the population is once again a number. So whenever the population increases, the GDP decreases. Both are metric data, both are numbers. So we can say that they have negative relationship. So similarly, with respect to industry index and GDP. So whenever the GDP increases, the industry index also increases. They have positive relationship. So in order to find influence of one variable on another variable, we can do significant impact or influence test. But in case if one of your variable is categorical and another is metric, you can do only significant difference test. Why? Because that is what is sound logical. For example, you are going to check the mileage of two vehicles. One is Activa and another is Jupiter. So Activa and Jupiter is a categorical data. Mileage is a metric data. Activa mileage is 42 and the Jupiter mileage is 46. We could say only significant difference in mileage. We cannot say significant association in mileage or significant relationship in mileage. So it will be sound illogical, right? So that is what. So if two data are categorical in nature, you need to perform significant association test. What test you need to perform? You can either do chi-square test or you can do correspondence analysis. Say, for example, the example what I given, smoking and cancer. Everyone try to mute yourself, ma. In case if at all, if you have doubts, kindly unmute and ask me. Okay, so when it comes to significant relationship test, you can do only correlation analysis. For this, both the data has to be metric. The example is GDP and industry index. So for this, in there is significant relationship, you can also go for regression analysis. Then comes the t-test. When one data is categorical categorical nature and another data is metric in nature, you need to perform t-test. There are many types of t-test, like one sample t-test, independent sample t-test, ANOVA, paired sample t-test. If the sample is greater than 60 or if the sample is greater than 60 and the data are normally distributed. So in case if your data are not normally distributed and your sample size is less than 60, it is better to go for non-parametric test. That is Mann-Whitney test, Wilks-Ensign rank test, and Kruskal-Wallis test. So these tests are completely a replication of the before test, that is independent sample t-test, ANOVA test, and paired sample t-test. Okay, so now let's get into the topic. So now let me open the SPSS. Prior before that, let me summarize everything. So what I said, we do statistics only for 4 important reasons. One is to identify whether the two variables or association or having association, or the second is two variables or more variables or having significant relationship with one another, or one variable is influenced by many variable, or to find is there any significant difference in the variables considered, and finally is the descriptive statistics. So now let me open the. So now is everything clear till now? Because since we are running short of time, I need to cover many topics. So that's why I'm going a little bit fast. But am I easy to understand? Have you understood till now? Is everything clear, ma? Okay.
Sir, I have one doubt.
Yeah, please, ma.
Sir, is there any way that we can justify the use of different tests that you have mentioned?
What is it, ma?
So the tests you have mentioned, is there any categorization to those tests that at this point you will use this? Sir, like you said
Hmm.
about categorical and metric variables,
Hmm.
we can use one sample t-test, independent sample t-test,
Yes, there is.
ANOVA, paired.
Yeah, for each and
So how you
every.
can differentiate?
Yeah, that I will tell you, Ma, because if I teach right now, I may not able to show you the scenario. Because in SPSS, if
Oh,
I show you the scenario, you may better able to understand. Anyhow, you asked me, let me explain. If you have a standard value, let me repeat, if you have a standard value, say for example, you are running a service center for a Honda Activa. The Activa company have told, the Honda Activa company told that my Honda Activa will give me a mileage of, on an average mileage of 42. So you are going to test nearly 10 vehicles and you have found the mileage to be 40, just 40. So you see the two mileage is difference, right? So one standard value is given, and if you're going to compare against a metric value, then you need to perform one sample t-test. But in case if there are two groups, say for example, Activa and Jupiter, there are only two groups, you need to check the mileage, you should go for independent sample t-test. If there are more than two groups, then you have to perform ANOVA test. And in case, if you are going to conduct a same study with the same population at a two different time period, you need to perform parity sample t-test. I will teach you, Ma. I will teach you because we are running out of time. That's why. Okay. Have you got? So
yes, sir.
like this, we have scenarios. Let me open. Let me project my SPSS. That is okay. Is my let me just hold on a minute. Just hold on a minute. Uh, okay. Okay. I think I'm sharing my entire screen. Actually, this is the questionnaire. This is the questionnaire. Actually, this deals with a training need analysis in a software industry. Okay. So you see the objectives are very clear: to study and understand the concept of training need analysis, to identify the important performance gap, to conduct organization task performance. These are important factors identified through review of literature, to analyze, to estimate, and to offer suggestion. For each and every objectives, from the third objective to fourth objective, we need to have a separate section in the questionnaire. Then only we may able to satisfy our the audience, that is during the Viva, because end of the day, they will be asking you how you have fulfilled your objective one, how you have fulfilled your objective two. So we have to be in a position that I have made a separate factor or made a separate section in my questionnaire to that deals completely with the objective 3 or 4. So that's how this questionnaire is framed. You see, all these questions are categorical data. You see, gender is a categorical data, age is a categorical data. If I put age dash, it could be of any number. Then at that point of time, it's a metric data. But right now, it's a categorical data. You see marital status, income level, totally. These are categorical data. And you see, this is also a categorical data. And but this factor, the drivers for conducting a training, it has a Likert scale based question from strongly agree to strongly disagree. And since the population size is more than 385, we are going to consider this. I think please mute yourself, ma. Okay. So at that point of time, it becomes a metric data. So like this, we have entered this entire questionnaire into SPSS. How to do this? So to do that, okay. So what you have to do first is that in order to enter the question, let me go to the questionnaire. Say, for example, if I wanted to enter this entire, let me Yeah. Let me start with the demographic profile. So the first question is gender. Okay. So first what you have to do is that you need to type the question here in the label. And you see everything have came out. Everything have came out. And I'm going in the name, I'm going to type instead of VAR001, I'm going to type it as D1. That is demographic question 1. Because in the data view, we have two views, my SPSS. One is a variable view where you type the entire questions and the options and you type the scale here. And whereas in the data view, you will be typing the entire data set. You will be copy pasting the entire data set. So gender. So what are the options available for gender? You see male and female. So that option has to be typed in the values. In values, it will be asking. The first is male, right? So I'm typing 1 as male. So I'm telling the SPSS that if the value is 1 in the data view, it corresponds to male. Similarly, if it is a 2, then it corresponds to female. So I am giving a command. Because the SPSS doesn't understand any sentences or word, it understands only numbers. So I'm telling that 1 means male and 2 means female. Similarly, I'm going to type the second question. So what is the second question? Is age. So what are the options? 1 is between 20 to 25 and 2 is 26 to 35 and 3 36 to 45 and 4 46 to 55 and 5 so greater than 55. So like this, we need to add question. We can also copy paste. Say for example, yeah, let me copy paste this entire thing. So competencies, just copy this, Control C and copy paste. You see the entire question is being pasted. And I'm going to rename this as D1 because this is demographic question 1 and this is demographic question 2 for easy identification. And this is competency 1, C1, sorry, C1, C2, C3, C4, C5, and it goes on. And the options are from strongly disagree to strongly agree. Let me put it in short form, SD, strongly disagree. Actually, it is better to put options from strongly disagree to strongly agree. Because I tell you what, when it comes to mean score or rank analysis, you will be finding difficult in case if you have put strongly agree as 5 as a value 5. Okay, that I will be teaching you. So add 1 and 2 as disagree and 3 as neither agree nor disagree. 4th is agree and 5th is strongly agree. So now I'm going to copy paste even these options. And the most important thing what you have to do is that you need to select the scale. We know gender is a categorical data. You see 3 circles. The 3 circles are not touching each other. If you take a close look, they are not touching each other, which means they are categorical data. This is also categorical data. And you see this is a Likert scale based question. So this is a Likert scale based question. So taking which means it's in the form of strongly disagree and disagree, agree. It goes like steps, right? So we can choose ordinal or you can also choose scale. Since we have a significant amount of population size or sample size, you can also choose scale. Here I'm going to choose ordinal. So I'm going to copy paste this. This is how you have to create a questionnaire. You have to create a questionnaire in the variable view. So how to feed the data, how to feed the data, that you have to do it in the data view. Say for example, here I have the data set. Yeah. So this is the questionnaire. Yeah. So this is the data set. So what I do is that I will copy paste this data set. This is the data I have collected through the questionnaire and then fed into Excel sheet in the form of numbers. We know D1 correspond to gender and D2 correspond to age. So I'm going to copy paste this. Nearly 463 respondents. Similarly, I'm going to copy paste the competencies. So this is how you need to copy paste the data set. So I hope now you have understood how to type the questionnaire into the SPSS and how to copy paste the data set into the data view. So SPSS has two sections. One is a variable view where you type the question, where you type the options, and you select the measure. And here in the name, you select you rename for easy identification in the data views. We see it is D1, which means gender, D2, demographic question 2, competency 1, C3, C4, C5. And if you see, if you take this one, it will be somewhat little bit clumsy and it is not easy for you to understand. So it is always advisable to name something that is easy for you to understand. Okay, so now you have understood how to feed a questionnaire into an SPSS. Okay, now let's perform an analysis. Now let us perform an analysis. Let us start with the easy analysis. Say for example, how to create a simple percentage analysis and how to create a chart. How to create a chart. So to do that, what you have to do is that you need to click analyze. Till now, is everything clear, Ma? Do you have any doubts? Students? Is everything clear till now? Can I move ahead? Yeah, in the chat box. Okay, okay. So well and good. So now let us do some graphical and descriptive statistics together. So to do some descriptive statistics, or let me start with a simple percentage analysis. So to do a simple percentage analysis, click on analyze, click on descriptive statistics, click on frequencies. Let me select, I want simple percentage analysis for all my demographic questions. Say, what are my demographic questions? Gender, age, marital status, education qualification, income level, and total year of experience. These are my demographic questions. So how to generate a chart? If with respect to a simple percentage analysis, you can create three types of charts. One is a bar chart, second is a pie chart, and generally histogram is not done for these kind of demographic questions, generally done for secondary data or sometimes done for our particular questions which has a Likert scale based or metric data. Okay, so let me tell you how to create a bar chart along with the percentage analysis. So click on the bar chart, click continue and click OK. Now you will be getting the output file. Oh no, there is no data set here. Okay. Yeah, now we got the output. We see gender. Among 462 respondents, 340 are male and 122 is female. Similarly, age, a simple percentage analysis. Here is the frequency and here is a percentage. These are not much enough and much needed. And you see a bar chart is been generated with the frequencies. Similarly, if you want pie chart in terms of percentage, what you have to do is that you need to click analyze, you need to click frequencies, and in the chart column, you need to select pie chart instead of bar chart. And then click continue and click OK. Now you will be getting the output with the, with the pie chart. So this is a two forms of visualization that you can do for a simple percentage analysis. In case if you wanted to compare two categorical data, and generate a graph, what you have to do is that, you need to click Analyze tab, go to Descriptive Statistics once again, click on the cross tabs. Let me consider two questions. Are you aware? Yeah. How frequently training is provided? This in one column with respect to gender. I just wanted to know how frequently the training is given in an IT company with respect to gender, male and female. So here, if I wanted to graph for two categorical data, here this for simple percentage analysis, for each and every variable, the graph is generated. For example, gender, you see a bar chart, only male and female. As a gender, as a bar chart is generated. Similarly, for with respect to age, the bar chart is generated. If you wanted to compare two data and generate a chart, so what you have to do is that you need to click on Analyze, go to Cross tab. Go to Cross tab. You will be getting this. And what are the two variables what you are going to compare? So that should have options mark. It should not be a number. So you need to select row and column and click on Display Cluster Bar Chart. And if you click OK, you will be getting the chart. You see, for male and female, for male, frequently, majority of the, frequently or sometimes or always, they are getting training. Similarly, with respect to females, once again, it's high. So we can say in IT company, irrespective of gender, they are given training. So this is what is the interpretation. So let me repeat. So in order to, or in case if you wanted to generate a histogram, where the histogram is used, I have a different data set for this. Say for example, you see this. This is a secondary data, This is a secondary data. Agriculture product export. How in terms of crore rupees and in terms of metric ton. So I wanted to know whether the data, you see, this is an agriculture product export from India from the year 2006 to 2022. So I wanted to know whether this data, the metric tonnage, how far the agriculture processed food product export is distributed, is the data or normally distributed or not. The best way to check whether the data are normally distributed or not is a histogram. So once again, to perform a histogram, click on Descriptive Statistics, select the data. So let me select the metric data. And in the chart, I'm going to select histogram. And I'm also going to check box show the normal curve, because using the normal curve only, we can clearly say whether our data are normally distributed or not. Yeah. Yeah. Majority of our data lies within the normal distributed curve, but here and there are many spikes, which means the data are not much normally distributed. It requires first difference or second difference. That I cannot teach you in SPSS. That should be taught in a different session. Okay. So this is how you can, and you can also create different types of graphs using the tab called graph. Generally, you will what all the charts we use: bar chart, area chart, line chart, pie chart, box plot. Box plot is also once again is very similar to the normal distribution curve. Let us click the box plot. Let me select this filter. So this is this box plot says once again the data are not normally distributed. So, and you can also generate many types of graphs. Say, for example, if you want to build a chart, click on OK. Whatever be the data, say for you wanted to create a bar chart, just put this here. Whatever be the x-axis or y-axis, you can do that. Say, for example, year has to be in x-axis and let this be in y-axis. If you click OK, the chart will be generated. You see, the chart is generated. So this is also an easy way to generate a chart. So the chart can be built in different ways. One, if you're going to deal with the data, just a single variable, if you're going to generate a bar chart or pie chart, you can click Analyze tab, go to Descriptive Statistics, click on Frequencies, click on the data for which a chart has to be generated. And in the chart column, you can either select bar chart or pie chart. Or if it's a secondary data, you can also create a histogram. Or else, you can specifically go to Graph, click on the chart, click OK. If you want bar chart, it will be there. If you want line chart, it will be there. So if you want line chart, just place it here, select the data. Say, for example, in the year, this one, and agriculture product in this one. If you click OK, the line chart will be created. So this is how the charts are built in SPSS. Actually, I'm covering the most important topics, ma. There are few other ways, but I don't want to touch up because it may consume time. We don't have much time. Okay. So this are the ways. So now let us go to a descriptive statistics. Is everything clear as of now, ma? Students? Okay, so well and good. Yeah. Yeah, tell me, ma. Anyone, any questions? Okay. Okay, now let me teach you about the descriptive statistics. I told you, right? Descriptive statistics, say, for example, yeah, the descriptive statistics generally deals with the following aspects, that is mean, median, mode, skewness, kurtosis, standard deviation, variance. So this and standard error, most probably. So these all together creates a descriptive statistics. So I told you, right, when it comes to statistics, it could be classified into two types. One is descriptive statistics and inferential statistics. So descriptive statistics generally tells whether the data are normally distributed, that is central tendency, or the data or how far the dispersion is, how far is the distribution is. And the inferential statistics is about significant association, significant relationship, influence, and difference test. So coming to the point. Uh, yeah. So I told you, right, descriptive statistics, technically speaking, deals with the following aspects. In order to perform descriptive statistics, you can either click on descriptive statistics, or you can also do it in the frequency. Let me teach one by one. Say, for example, I wanted to know the descriptive statistics of both agricultural product export with respect to rupees and with respect to metric ton. Let me consider one data at a point, at a time, so that you may be able to better understand. And in the options, I wanted to know what is the mean, what is the skewness, what is the kurtosis, what is the range, what is the standard error, what is the variance. We don't have median and mode here. So in descriptive option, the important problem is that you may able to obtain only mean, standard deviation, variance, range, kurtosis, and skewness. But in case if you go to frequency tab, that is clicking analyze, descriptive statistics, frequency, and if you go to statistics here, you can select everything: mean, median, mode, and sum, standard deviation, minimum value, maximum value, range, variance, standard mean error, skewness, kurtosis. So frequency statistics is the best way to do the descriptive statistics apart from going into the descriptive. So if I click OK, and then if I click once again OK, I will be getting the output. So I tell you what does this mean. The best example is that you are running a service showroom, let's say Honda Activa showroom itself. So you have checked the mileage of nearly 10 vehicles, 10 Honda Activa, and it was found to be the mileage of nearly 42 on an average. So this on an average mileage is nothing but the mean. And median is nothing but say for example you are a lazy person. Say, for example, I am running a showroom and I am a lazy person. Instead of checking the mileage of each and every vehicle, what I'm going to do is that I'm going to arrange all the vehicles, and then I'm going to select the middle vehicle, and then I'm going to check the mileage. So that is what is median. So median is literally nothing but selecting the middle value, And mode is the most repeated value. Say, for example, you have checked the mileage of nearly 10 vehicles, and you have seen that out of 10 vehicles, nearly 4 vehicles is giving the mileage of 42, which means mode is nothing but the most repeated value. So mean is the average value, median is the middle
Mensural
value.
cycle is measured from, ये तो ऊपर भी आ गया ना, फिर ये repetitive information हो गई.
What is it? What is it, ma?
Menstrual cycle is measured from the first day of your periods to the day before your next periods. The average length of the menstrual cycle is 28 days, but everyone's cycle is different. For example, teenagers might have cycles. ये तो same चीज आ गई ना.
I'm not getting you, ma. I'm not getting your question clear. Please repeat it, ma. Can anyone explain? Okay, ma. Okay, ma'am. Monica, in case, try to articulate your question, ma'am, because I'm not getting your question clear. Or if anyone understood the Monica question, please put it in the chat box. Okay. Okay. So mean is average value, median is the middle value, mode is the most repeated value, and skewness and kurtosis. I tell you what, skewness is something is a measure of the flatness, the measure of flatness along one side or the other side. Say, for example, I am a teacher for you all, and I have given a question. I'm giving you a test in which all the questions are very, very difficult, which means majority of my students will be getting less than 60 marks. You see, this accumulating all points on one side is nothing but the measure of skewness. So in case if I set the question paper in such a way, let me put it in a paint. Yeah. So we all know this is normally distributed curve. Generally, if I give a standard question, what least will be getting more than 90 marks. And least will be getting less than, say, 30 marks. So this is normally distributed curve. Majority will be getting the marks between 30 to 80 marks. Let this be 80. So in case if I set a question in such a way that it is very, very difficult, so what happened is that majority of the students will be getting less than 60 marks. So this is how the normal distribution curve will be. In case if I set a question in a very easy way, very least will be getting a fail mark and majority will be getting the high marks. So this is what is a measure of skewness. The skewness will tell whether the data or the data points are accumulated in the left corner or right corner. If it is not, if it is less than 1 or less than 3, then we can say that there is no skewness. And kurtosis is a measure of peakness. The best example is the stock market. You might have seen many volatilities in the many stocks. So if there is huge volatility, that is measured in terms of kurtosis. So kurtosis is nothing but the measure of volatility or the measure of peakness. So now let us see the data. Now let us see the data, this data set. So what is our data set here? Is the metric, is the, uh, yeah, yeah. You see, this is our metric value. This, this is our value. And mean, as I stated before, it's an average of all these value. Let us check whether the average of all these value is 1 point something what has been given here. So let me go to Excel. Yeah, let me copy paste these values. Sorry. So let me, so now I have copied these values. I'm going to paste these values. I'm going to check the average equal to average of all these values. You see 1895069. Let us check with the output value. That is 1895069. You see, so the mean is nothing but the average value of all these things. So median is nothing but the middle value. So what is the middle value here? First, in order to find the middle value, we need to sort it down. I told you, right? First, we need to arrange and then we need to take the middle value. So let me arrange. Let me arrange values. So let me arrange. Let me sort from A to Z. Sorry, smallest to largest. And this is 1, 2, 3. So we have 17 values. So among the 17 values, which is the middle value? 9 is the middle value, right? 1, 2, 3, 4, 5, 6, 7, 8. And here 8. You see, so this is the middle value. That is 1885463. So this is the middle value. Let us check. You see 188. So this is the middle value. So median is nothing but the middle value after sorting it out. And mode is the most repeated value. You see the 708.67 is repeated somewhere else. I don't know exactly. Might be, yeah, it's given A, which means it's not repeated. It's the first value. Standard deviation is nothing but the value, how far a value is deviating from the mean value. So mean is nothing but this 1895069. So with this as a mean value, how far it is getting deviated, plus or minus. So it is getting deviated by 92291 plus or minus. So that is what is a standard deviation. So its square root is the variance and skewness and kurtosis. So we see the kurtosis value is 0.195, which is less than 1. Then we can say that there is no kurtosis, which means there is no measure of peakness, almost flat. And skewness is minus 0.759, which means the data are skewed along one side. And minimum value is 14708. You see, this is the minimum value. And maximum value is 31558, where it is Yeah, you see this during the year 2008, the maximum export have happened. So basically speaking, descriptive statistics is all about the measure of average value, the middle value, the most repeated value, the standard deviation. That is how far the value is deviating from the mean value, and the kurtosis, skewness, and the maximum, minimum. So these all together, and the sum is nothing but the summation of all things. So this is what is descriptive statistics is all about. So now you have understood the first half of the statistics. What is the first half of the statistics? Is it descriptive statistics? Now we are going to enter into the inferential statistics. That is the significant association test, significant relationships test, significant influence, and significant difference test. Actually, I think there are many topics to be covered. And as of now, do you have any doubts, Ma? Is everything clear?
So can you please elaborate standard deviation again?
Standard deviation. Say, for example, Ma, this one. I told you, right? How far the value is deviating. Let me open Paint. Yeah. Okay. So, this is normal distributed curve. Okay. So let us see the output. So the mean value here, the mean value is 1895069. So this, yeah. So this is our mean value. This is a normal distribution curve, ma. So this is the normal distribution curve, and this point is the mean value. So what is our mean value? That is 1895069. So this is a mean value. So from this as a mean value, how far the value is deviating? How far the value is, oh yeah, how far the value is deviating? So it is deviating by either negative 922,991 or positive by 922,911. Let me show this in the Excel sheet itself, ma. Say for example, we know our average value is this one. Average of all this. So what is the standard deviation? Standard deviation is what we have identified as this one. That is, let me copy paste. So what I'm going to do is that I'm going to this minus this value. Similarly, this plus this time standard deviation value. You see, majority of our value lies between these two values. If you take a close look. Let me put in conditional formatting so that you may better able to understand. What is the value? And you see the normal distribution, majority of only two values up and two values down are not coming between these standard deviation value. Other 95% of our values are coming under these values. So mean, the standard deviation is nothing but the how far the value is getting deviated from the central value. That is the mean value. Now you got me, ma?
Yes, sir. Thank you, sir.
Okay, so tomorrow we need to start on time, right on time by 7 p.m. itself. So try to log in as soon as possible because we have lots and lots of topics to be covered, because at that point of time need to teach you chi-square analysis, correspondence analysis, independent sample t-test, ANOVA, if possible MANOVA, and also correlation and regression analysis. See, We don't have time to go for other kind of statistics, like apart from these, like regression, which is the predictive analysis that we can do, or we will see tomorrow. But there are other kinds of statistics that it can be done using SPSS, like factor analysis, this exploratory factor analysis, the cluster analysis, and the non-parametric test, having a different set of medians and optimal scalings. These kind of different kinds of analysis can be done. Even that in case if in future period of time, if you are going to have a separate session exclusively for SPSS for 1 week, that at that point of time I will teach you, ma. But in the next session, try to make sure you all log in on time, because we need to cover so many topics. That is, we need to cover these topics. That is the chi-square and correspond analysis, that is significant association test, see the correlation analysis, that is significant relationship test, regression analysis, that is significant influence test, and different types of independent ANOVA, and if possible one sample t-test and other things, that is significant difference test. So is everything clear today, ma? So what all I thought was, the first I thought about the types of statistics, descriptive and inferential. Descriptive, I told it deals with mean, median, mode, skewness, kurtosis, standard deviation, standard error, variance. This is what is descriptive statistics. And significant association is nothing but, and with respect to data types, there are only two types of data. One is categorical and metric. If two data are categorical in nature, then we need to perform only significant association test. What test? Chi-square or correspondence analysis. If one data is categorical and another data is metric, we need to perform only significant difference test. If two data are metric, we need to perform significant relationship test. If there is significant relationship, we can go for significant impact test. So this is what we have discussed. And then we have discussed how to feed a data into an SPSS, how to feed the questionnaire into the variable view, how to feed the data set into the data view. And then we have discussed how to perform a graph, how to create a graph using analyze, frequency, that is bar chart and pie chart. And other graph options, what you can do is that you can click on the graph tab. Sorry. Yeah, you can click on the graph tab, and you can click on the chart, and then you can create your own chart selecting the data. And using cross tab also, you can create, you can compare two variables and create a chart. So we have seen how to create a chart, and then we also seen how to create a histogram. And then we have also discussed how to perform a descriptive statistics. So this is what we have seen today. Is everything clear today? Do you have any doubts? Students? Yeah, in chat box. Yeah, Monica was asking some question, please. I didn't have anyone. I think, don't worry, Mama.
Sir, I think I'll get
Yeah,
my answers tomorrow. I
okay,
wanted to
ma.
learn correlational analysis.
Correlation analysis. Yeah, I tell you,
Yes,
ma,
sir.
the basic thing is that when you have both the data or metrics, say for example, in social science studies, many people do correlation analysis with the demographic profile. That is completely wrong. You can do correlation analysis only between the two factors or the two variables with the Likert scale options or having a metric data. So if you wanted to know the relationship between the two variables, you can do correlation analysis. There are two different types of correlation, but we are going to see only one type of correlation because of the time constraint, that is Pearson correlation. But in case if there is a categorical data, we can also do a correlation analysis for that, but for that there is a separate procedure, ma. Trend analysis. Yeah, I tell you what, trend analysis is once again, a regression analysis is the most important analysis, ma, through which you will forecast. Actually, trend analysis is, say for example, it comes under that. It comes under, actually, there are various types of trends. Say for example, exponential trend, we have a sine trend, we have a logarithmic trend, quadratic trend, cubic trend. There are various types of trend analysis. All these are nothing but the regression estimates. Tomorrow I will teach you even the regression analysis. In fact, using the regression analysis, you can able to do your best forecasting. That I will teach you tomorrow, ma. Narrative analysis, in the sense, I didn't get you. What is this actually? What is this narrative analysis, ma? Okay, so I think this is more than enough for the day. In case, if at all, if you have any doubts in the previous session or this session, feel free to ask me in the tomorrow session, and come try to be on time. Okay, so can we wind up? So technical persons. Okay, ma. Thank you all. Thank you, God. We see. Take care. Bye.
Contact RCHUB International Foundation for Research and Education. WhatsApp 9888 231 231.